Hello everyone, welcome to Clash Encoder. So in this video we will see the question 525, that is contiguous array. So this is a medium level question and it has been asked for interviews in Amazon, Facebook and Google, etc. So let's see the problem statement, then I will explain you the question and the algorithm, then how we can solve this question, and also I will show you the code. So let's see, given a binary array, find the maximum length of a contiguous sub-array. So contiguous means continuous and it is a sub-array, not a subsequence. So that means it no index can be skipped in between, with equal number of zeros and ones. So that means we will be given a binary array. Binary means it will only consist of 0 and 1, only 2 digits. So it is a binary array and we have to find the maximum length, or we have to find the sub array which has equal number of zeros and ones. In this example you can see 0 and 1, it is only 2, length is 2. You can see this is the whole array is actually the sub array. You can see 0 and 1, number of zeros and ones are equal, so output is 2. In this array you can see this the sub array will be 0 and 1, because if we include this whole array, so it will have zeros will be greater than 1, number of zeros will be greater than 1, therefore it will be not a this condition will be not satisfied. So therefore the output will be 2. You can see either we can take this 0 and 1, either or we can take this 1 and 0, so output will be 2. And you can see, notice given that length of the given binary array will not exceed 50,000, so it is a fairly small number as compared to other problems. So let's see how we can solve this question. So actually if you start solving this question, this is a different example you can see. So if you start like solving this question, you will think that you will make simply two variables, that is 0 and number of ones, and what you will do is you will traverse over the array and you will keep incrementing. If you see this one, you will increment this one. If you see this 0, you will increment this 0. Then you will keep checking if in a if condition, that if the number of zeros and ones, these two variables, are equal, then you will simply update the result and you will keep continuing till that point, till the end. But this condition this will run in the first test case, this test case that we are given, but it will not run in the other test cases, because this is not the solution for this problem. This is actually not covering all the test cases. Now how is that possible? Because if you see, if we start from this point, you will count this. Okay, 0 will become 1 and 1 will this will be incremented. We have got 0, you can see, so they are incremented. Now if we see here, so 1 will be incremented, it will become 2. This is one variable. Now again 1 has came, so it will become 3. Now you will keep checking in every iteration if 0 is equal to 1. So you can see it is 1, it is 3, so not equal. So when you get this 0, you will increment this 2. So now you have 2 and 3, they are still not equal. Now when you reach till this point, you will get 1, so you will increment one variable, it will become 4. Now it is 2 and 4. Now you can see they are not equal, but this is not a correct answer. This will show result as 0. That means you had not found any sub array which has equal number of zeros and 1. But that is not true, because here you can see in this sub array that we given here, the maximum length of the sub array that has equal number of zeros and 1 is 4. How? You can see here, if we start from here, there will be no sub array, but if we start from this point, you can see two numbers of 0, 2 zeros and 2 ones. So that means there is a sub array, possible sub array which has equal number of zeros and 1. So therefore this solution will not work. So I have also tried this solution first time, but this will not work. So let's see how we can solve this question actually. So if you see carefully here, as we have been given a binary array, to solve this question we will simply make a simple change in this problem statement, not the problem statement exactly, but in this input array, and it will form a different problem statement that we have already solved. So that will let's see. So if you see here, we are given 1 and 0. So what if we convert this 0 to -1? If we write -1 instead of this 0, this array will become 1, then it will become -1. You can see 1 1 and this 0, so it is -1, so 1 will stay as it is. So now if you see, we have not changed the problem statement, but we have only changed the elements. Instead of 0 we have written -1. So problem statement is similar. We have to find the number of the maximum length of the sub array which has equal number of ones and -1s. So that is 0. You can see -1 denotes 0 here. So now if you see here, now the sub array which with equal number of ones and -1s, or you can say 0, will have always sum as 0, because 1 will cancel out the -1s if the number of ones and -1s are equal. So that means instead of this -1 we will like assume it to be 0, so the sum will be 0. So the actual sum will be 0, because you can see if we have got this 0 1 0, okay, so what will be the new array that we have formed? It will be 1 -1. Instead of 0 we'll write -1, then 1, then -1. If you try to sum this, so it will be, you can see this will be cancelled out, this will be cancelled out, so the sum will be actually 0. So this directly changes the problem to finding the sub array, the maximum length of the sub array with the sum 0. So actually you can see, if we have modified this array, it has become 1 -1 1 1 -1 1. Now we have to find the maximum length of sub array which has the sum as 0, the sub array sum which is 0. So let's see how we can solve this. So if you see here, what we will do is this is an array, so I will actually erase this. I will delete this. So this is a new array. So what we can do is, at this point we will find the sum. So it is 1. at this point sum will be, you can see this 1 plus this minus 1, it will become 0. Now at this point it will be 1. Now again at this point it will be 2. So now if you see here, it will be minus 1 plus 2, so it will be 1. Again it will be added, so 2. So now if you see at this point we have got 0. So that means at this point, starting from the starting position till this point, the sum of the sub array is actually 0. So it is that 1 are cancelled out by minus 1. So that means the number of 1's and minus 1's are equal, therefore they're cancelling out each other and we are getting the 0. So that means till this point the length is 2, you can see it is 2. So this will be our result. This will be our result till this point. So now when we go to this point, you can see this one has occurred and already this one has occurred. So it also signifies one thing. So you can see this one and this 0 is in between. So that means till this point, okay, the sum was 1. And in between what we added remained 0. The sum is same till this point also. So the elements that we added here had no influence on the total sum. You can see 1 remained 1 after adding. So that means the values added in between, it will be like minus 1, 1 and again 1 and minus 1. So they cancel out each other. They contributed 0 to the total sum till this point. So that means that there was a sub array which was having equal number of 1's and minus 1 that were getting cancelled out. That is why we are getting the sum as 0. So this is what our problem statement will be looking like. So what I told you here was like we will keep the count of, or we will keep the track of the 1. So here as I told you, we reached 1 here, and how we will check that this one was this one has already occurred. So we will use a hash map here because we have to store the indices also. So we will make the key as this one. So we'll make the key as this one and its index, that is 0. Index is 0, so 0 as its value. So now what we will do is, you can see again when we will get this one. Okay, when we will get this one, we will check if it already exists in map. So you can see it exists in map, so its index is 0 and the current index is 2. So we will do 2 minus 0, it will be 2. So that means we have found a sub array with equal number of 1's and 0's. So we have actually changed the 0's to minus 1. So we have found that possibly. So we will simply update our result to max of the previous result and the current value that we have got. So it will be 2 actually, because our result will be starting at it will be 0. So let's see the algorithm. So this was just a dry run. So let's see the algorithm. So you can see, first of all, this is the array that we have given, and these are the indices. So now we will update this array. So it will become, you can see, instead of 0. So you can see, first of all, we'll simply initialize our result. Initialize our result variable and the sum variable. So you can see result variable will be the final variable that we have to return, and the sum variable will be till that point how we are calculating the sum. Till that point, what is the sum? So you can use a different array also, but that will consume a lot of space. So you can simply use a variable to calculate till that point. So now then you need to initialize a map, or you can say in Python a dictionary, or in Java a hash map. So here I will use a map. So you can see we have initialized a map. So we will traverse over this array and we will maintain some variable. You can see this is our sum variable, and we will check if this at this point. So we are at this point. Okay, we are at this point. I is at this point. So now we will check this value. It is 1. So that means we have a sum variable. So this is a sum variable. We will simply add, because it is 1. You can see it is 1. So we will simply increment our sum. So it will become 1. So now when we reach, you can see this condition has been skipped. This is else part. So now when we reach here, you can see we will check if sum is equal to 0. As I told you, if at any point our sum is 0, so that means till that point, starting from the starting index till that point, the array has been cancelled out, because 1's and minus 1 were equal to that point. So that is why we are getting 0. So it is that we are getting the sub array starting from the starting index till that point. It is not starting from in between. So let's see. So this is that condition, and we will check else if sum is already in map. As I told you, if sum is this here, like 1 was already in the map, so that means the array in between that 1 till this one has not contributed anything to the sum. So that means it has equal number of 1's and minus 1. That is why it got cancelled. So this is for that condition. And else what we will do is, we will, like, this condition will run for this this particular iteration, because there is nothing in the map and the sum is also not 0. It is 1. So we will go to else part. It will be, you can see, map of sum. Sum is 1. Sum, and it will update it to the index. So index is 0. You can see it is 0. So now I will increment. I will come here. So I is here. Okay, you can see. So it is 0. So as I told you, we will substitute minus 1 instead of 0. So we will simply check this condition. You can see if number is equal to 1, so it is not 1, it is 0. So we'll simply subtract this one from this one. So it will become 0. So now our sum is 0. So that means it denotes something. So starting from the starting position till that point, the sum is 0. So you can see here this 1 and 0. So that means the number of 1's and 0's are equal, or 1's and minus 1 are equal. So let me actually change this. So I will make it as minus 1. You can see it will be easier for you. So you can see as we have updated our array, we will update our array. It will be actually not updating our array, it will be sitting at that point only, but I have updated for the convenience. So let's see. So as you can see, sum has become 0, so that it did know something. So now what we'll do is our result variable, you can see it was initially it was 0, so now it will be updated. It will be max of the previous result, that is 0, and the current index. So current index is 1. So here you can see you cannot simply return 1. So for this index where we have got some 0, we cannot simply return 1. It means that we will have to this index is 0 based actually. So you can see we will have to add 1 into it, because to make it 1 based indexing it will become 2. So now you can see we have got a sub array of size 2. You can see this sub array 1 and -1 got cancelled because they are at equal number of 1s and -1s. So output will be 2. So our result will be updated. You can see this condition will be run, this condition. So now our I will be incremented. So this condition will not run because this is, you can see, if, else, if and else. So this will not run. These conditions will be skipped and will be into next iteration. So now if you see here, we have got again 1. So this sum will be updated to 1. So now if you check this, this will run. You can see it will be added simply. Then we will check if sum is 0. Sum is 1. It is not 0. So that means we will check into this else if part. If sum is in map, so you can see sum is 1 and 1 is already in map. So that also denotes something, that starting from that point, in the map that we have indexed, so we have 0 index. So starting from this point till this point, the current iteration that we are on, the current index. So the sub array in between has not contributed anything to the sum. So that means its total sum, the sub array in between this point to this point is 0. So that means it doesn't contribute anything. So that means there are equal number of 1s and -1s. So therefore we will check here. So this index is 2, so it will become 2, and you can see this the result will be, result is 2 actually. So you can see it will be max of 2, comma, it will be current index I, that is 2, minus this index. So index of sum is 1, you can see 0. So index of 0, you can see it will be 2. So again it is 2 only. So you can see till this point the output will be 2. So you can see this we are considering this -1 and this one. So there are equal number of 1 and -1. So output will be 2 only. So till this point result is 2. Now we will increment to next point and it will again check. So our output will be, this will be incremented, it will become 2. So nothing will happen. Okay, nothing will happen. But here you can see it is 2, it is not into the map. So we'll simply add it to the map. So 2, it is occurring at, you can see, sorry, it will be occurring at index 3. So it will be 3. So now when we come to this iteration, this point, so you can see sum is this is -1 and it will become again 1. So we have not updated this -1, this one. So it has value as this index, you can see. So now again when we come to this point, this else if sum is in map, so sum is 1 and it is already in map at 0th index. So again we will update our result. The result will be max of 2 and this current index, that is 4, minus the map value of the sum. So you can see map value of the sum, this is 1 is 0. So that means starting from the 0th position till this 4 point, there is a sub array which has not contributed anything. So that means it has equal number of 1s and -1s. So you can see it will be 0. So now the max out of this will be actually 4. So our output will be updated to 4. This is what we were trying to do, and this is what we are trying to find, the maximum length of sub array which has equal number of 1s and 0s. And instead of 0s we are simply considering it as -1. So we can simply convert this problem into the finding the maximum length sub array with sum 0. So this is what our algorithm is, and the time complexity for this will be actually simply O of n time, because we are traversing the array one time only, and we are also using a hash map to store this these elements and indices. So therefore the space will be also O of n. So let's see the code, then I will also submit the solution. So let's see the code. So I have written the code in the C++. Also I will provide the code in the description also. If you have any doubts, so you can ask in the comment section below. So you can see, first of all, we have simply initialized the result variable and the current sum. Then I have initialized a unordered map. So here you should use unordered map. If you use map, so the time complexity will be like bit higher. So if you use if you use simple ordered map or simple map, so time complexity will be higher. So I suggest you use this unordered map. So now you can see I will run a loop. So it will run from 0 till the whole length of the array, and we will check at that point if that is equal, the value is equal to 1. Simply we will add it to the our current sum. Otherwise if it is 0, so we will consider it to be -1. So we will subtract this -1 from this current variable, and we will check if it is 0. So that means starting from the 0th index till that point, the sub array has equal number of 1s and 0. So we will simply update our result to the max of the previous result. So you can see result is 0. So previous result and I plus 1. So this is what this condition will do. And other cases are like if our sum that we have got is already present in the map. You can see map.find is not equal to map.end. So if it is already present, this condition means if it is already present, so we will update our result to the max of the previous result and the current index that we are on. Like here we were on 4th index, and we were on the 4th index, and the value that we had in the map for that current sum, that is 1, was 0. So it was 4 minus 0. So maximum out of 2 and 4 was 4. So our result was updated to 4. Otherwise, both the values are not present. When we are adding this element, you can see when we are adding this element, so the value are that means the value was not already present. So we will simply add it to the map. So map sum is equal to the index I. So you can see this is what we are doing. So now at the end, when this all iteration is run, so we will have the maximum length of the subarray. So it will simply return this return result. So let's submit this solution. So you can see I also tried the first method. First of all, I also thought that it will work, but it didn't work, you can see. And then you can see here I used a simple map. It had a lot more time complexity, but the unordered map has like bit less time complexity. You can see it ran faster than 91% of solutions and took less memory than 89% of solutions. So I will also provide the code in the description. Thank you for watching, guys. Do like this video and subscribe this channel for more such videos. Thank you for watching.